Hello class. Today we get to do our last lesson. Besides, we'll have a review coming up this Wednesday, and we will not have class on this Friday. But today, Monday, April 27, we're going to be assigning 9.6. It's due Friday, May 1. It's our last assignment that we get. All right? So that's where we're going here today. It shouldn't be too terribly long. I would like to review a principle that we've been using the last few lessons. The reason we're reviewing this is it leads us into another similar concept for today. You recall we've solved second-degree equations by factoring. An example would be like this: x squared minus x minus 12. I want you to really focus on what I have written in red here for now. When we did this problem, we used this principle. If I have two things that are being multiplied and their product is 0, we know either the first thing, A, has to be 0, or you know that the C has to be 0. In other words, we would know the A has to be a 0 or the C has to be a 0. And technically they could both be. But we know at least one of these has to be true. That was an important principle when we solved over here, because we factored this into x minus 4, x plus 3. Now it's crucial that you recognize this x minus 4 is like the A in parentheses. This x plus 3 is like the C in parentheses over here. Because their product equals 0, you know that either this first part, the A, has to be 0, which means x minus 4 would be 0, or the second part, the C, has to be 0, which would mean x plus 3 has got to be 0. So we go from there to there. We say the first part has to be 0, the first factor, or the second factor has to be a 0. And then we solve each of those for x. And we get x equal to 4, x equal to a negative 3. You can check them out. 4 squared is 16. 16 minus 4 minus 12 works. If I put a negative 3 in here and squared, I get 9. Minus a negative 3 is plus 3. 9 plus 3 is 12. Minus 12 equals 0. Both answers work. Don't lose sight of the principle here, because we're going to do something similar but different today. It's really crucial that you pick that up, okay? Notice this equality sign in the red. What I'm referring to is that equality sign right there. The fact that it was equal to 0, that's how we were able to conclude A has to be 0 or C has to be 0. Today, as I said, we're going to do something similar. But we're going to have a slight alteration. We're not going to have an equality sign, but instead we're going to have an inequality sign. Again, going back to the previous page, that means this equal sign right here would be either a greater than, or that equal sign would become a less than. We're going to look at both scenarios. It is a little tougher to understand, so kind of dig in here, because here we go. As I mentioned, we're taking the equality sign out, but instead we have an inequality. Now, this is different. If two things are multiplied and they're greater than 0, well, there's a lot of possibilities, but I'd like you to notice that if I took a positive 7 for A, C would be a positive, let's just say 8, I'm making that up. Notice that I'll get 56, which is greater than 0. Why was this answer greater than 0? Not so much for the 7 and the 8, but that I took a positive number times a positive. So one way this could be true is if both A and C were positive numbers. However, it also could be true if both of them were negative numbers, because two negatives give you a positive answer, which is again greater than 0. So we have these possibilities. These two, A and C, could both be positive, or these two, A and C, could both be negative. We would say a positive times a positive could be put in there for A and C because two positives give you a positive answer, or I could have two negatives because two negatives multiplied give you a positive answer. So these parentheses can either both be positive or they can both be negative. Well, to make them positive, like to make this positive right here, it means that A has to be greater than 0. If A is greater than 0, A is positive. C has to be greater than 0. If C is greater than 0, C is positive. So to get two positives, I can make this statement. Notice we connect them with the word and. A is greater than 0 and C is greater than 0 at the same time. They have to both be positive at the same time. Or they could both be negative. For this A to be negative, we have to make it less than 0, and at the same time, the C must be less than 0. This right here in red, these three steps are crucial that you understand. Don't be afraid to rewind this, listen to it again. It's super important that you understand this logic. Because now let's use it. We're going to apply that to that second degree equation that we had. There was the equation, but notice I have a greater than sign just like I have right there. Well, I can factor this just like we did before. Now this x minus 4 is just like the A. The x plus 3 is just like the C. They can either both be positive. Excuse me a second, I have to take this. Hello? Yep. All right. Well, the good news is it's all covered, right? That's good. All right, then I'll keep waiting. Thank you. Yeah, thanks. Bye. I'm so sorry for that delay. Let's go back to where we were. Two things are being multiplied. The answer is positive. Means they could both be positive, or these two things could both be negative. So to make the first one both positive, we take the x minus 4. To say it's positive is to say it's greater than 0. It's just like saying that it's a positive quantity. X plus 3 is greater than 0. It's like saying it's a positive quantity. Or, now these are both could be negative, because remember a negative times a negative is a positive quantity. So to make x minus 4 negative, we make it less than 0. And at the same time, we want this one to be negative. And we solve each of those, and we get this expression. Now, listen real carefully to the next little stretch here. This is kind of tough for a lot of students. I'm going to graph this once. What does it mean for x to be greater than 4, and at the same time, it's got to be greater than negative 3? Well, I'm going to put a negative 3 over here, 0 and 4. Notice x greater than 4 would be all of these points shaded that way from 4 above. Greater than a negative 3 would be from a negative 3 all the way above. Not so hard so far. But now this and. Remember they had to both be positive together. This one positive and that one. That's why I have that and in there. So I'm looking for the numbers that are in both of these. I'm going to say that again. I'm looking for the numbers that are in both of these. Notice numbers aren't here, aren't in either one. These numbers right here are only in 1. But these numbers from 4 up are in both. They're shaded up here in that one, and these numbers right here are shaded in the lower one. That means these numbers are the ones that are in both. So those are the numbers that I want in my answer, x greater than 4. That's how we get that. Let's go back over here once. Notice, if I were to graph these two, I have a -3, 0, and 4. Less than 4 is all of these numbers. Less than -3 is all of these numbers. They have to both be negative at the same time to get a positive number. Means both of these have to be true. I need the numbers in both. I'm going to say that again. I need the numbers in both of those. These numbers over here aren't in either one. These numbers right in the middle aren't in both of them. They're in one of them. But these numbers are in both. Those are the numbers that I need for my answer. Well, what are those numbers? Those numbers are x less than -3. So these two get combined to be x less than a -3. That's what I mean by combining them. Don't be afraid to draw a separate graph. Okay? Now we have to draw a final graph here. Okay? The final graph. I have a -3, 0, and 4. Notice this word or. That means I need these points now, or I need those points. A moment ago, we were focusing on the word and. When I used the word and, they had to be in both, which means we got to these. But now it's or. They have to be in one or the other. Well, greater than 4, that's all of those points. Less than a -3 is those points. That's my final answer. This is a tough concept for a lot of students, all of this. Again, don't be afraid to replay this 2 or 3 times. It's crucial that you understand how I used this concept in red, how I put that in context now of this problem, all right? I'm going to be using that problem again, that same concept, another time. Here we go with some more examples. Okay, solving this one. Factoring isn't as easy. Might take you a little more practice, but the factors turn out to be those two numbers. You can check it out. You'll get a middle term of a -5. Notice though again, greater than 0. It's not equal to 0 like we had a few lessons back. This one's greater. That means either both of them have to be positive, like this, or both of them have to be negative at the same time, like this. That means these two parentheses have to both be positive or greater than 0. These parentheses have to both be negative over here. For A to be positive, A has got to be greater than 0. For C to be positive, C has got to be greater than 0. Or I can have them both negative. For A to be negative, it's got to be less than 0, and C has to be less than 0. I'm going to now apply this red to this problem right here. So let's do that here together. Both of them have to be positive. So I take the 2x plus 3, make it greater than 0. And at the same time, I take the x minus 4 and make it greater than 0. Or, that's this or right here, they could both be less than 0. That would mean they're both negative. So I could take 2x plus 3 make it less than 0, and at the same time, x minus 4 is less than 0. Now we just solve for x in each case. Bring the 3 across, it's negative, divide by 2. Here I bring the 4 across, gives me x greater than 4. And I'm using the word and, that means they have to be in both. Or, here x is less than a negative 3/2. And at the same time, x is less than 4. Some people can immediately just look at these two and know which one we say graphs the points that are in both. One of these represents the points that are in both of them. The other one does not. Some of you I know can just look at that. But if you're not one of those people, don't be afraid to take a drawing. I'll go up here with the drawing. Negative 3/2 and 4. Greater than a negative 3/2 would mean to the right. Greater than 4 would be to the right. Do you see that these are the points that are in both, the ones greater than 4? So we say that greater than 4 represents the ones that are in both. That's our final one from there. Now we go over here. Same kind of graph. I want the points that are graphed in both. I have a negative 3/2, 4. Less than a negative 3/2 are these points. Less than 4 are those points. These points aren't graphed at all. From here to here, they're only in one of them, but these points are graphed in both. What are those points? They're the ones less than a negative 3/2. We say this one represents the points that are in both of them. Again, some of you can do this mentally right to there and from here. Others need to graph this out. Just make sure that it makes sense to you when you're done. I have the word or now, so I got to graph these or those. So I have a negative 3/2. That's for this one. And a 4, positive. Greater than 4 means all of those. Less than negative 3/2 means all of those. Those are my answers. That is solving this inequality by factoring. I show the answer with a graph because on an inequality, there's an infinite amount of answers. Again, make sure you understand what's in red here and how we took that and applied it. That's crucial. I chose this one because sometimes people have a hard time factoring this one. There's no number to factor. Like this previous one, do you remember that we had a number here, a minus 12? And that's how we had numbers in there. But there is no number here. We can always take out an x in that situation. Sometimes we can take out a number too. For example, this one I could factor to a 3x and an x plus 4. Greater than 0. We don't normally put parentheses around the 3x, but I could, so that it reminds us of parentheses a times parentheses c. Same principle is what we've been using. Okay? Well, let's see if we can do it without having the red right here. Remember, they could both be positive, correct? That would make it greater than 0, so let's make both of them positive. 3x is greater than 0, and at the same time, x plus 4 is greater than 0. Or they could both be negatives, because two negatives multiplied would be greater than 0. So I take the 3x, make it less than 0, and at the same time, I'm going to take the x plus 4 and make it less than 0. Now I solve for x. I divide by 3 here. Notice that just still stays x greater than 0. I divide both sides by 3. Here, bring the 4 across, greater than -4. Or divide by 3 again. I divide both sides by 3. I get 0 yet on that side. And at the same time, x is less than -4. Well, which one takes over? I could graph each of them separate, but I'm hoping greater than -4, greater than 0. You see greater than 0 are the points that are in both. Less than 0, less than a -4, these will be the points that are graphed in both. So those are my answer then. I have a 0 and a -4. Greater than 0 would be this. Less than -4 would be this. One more detail. If this was an equality sign here, okay? If that was an equality sign, that equality sign would go all the way through. And I would have these filled in rather than an open circle. That's the only difference when there's an equality sign. We've done stuff like that in the past, so that's not too terribly difficult, I don't think. Okay, here's another one, similar kind of reasoning. I have a quotient greater than 0. Well, what's the only way that can happen? Would you agree a positive divided by a positive number will be greater than 0? So both of them could be positive. Or a negative divided by a negative would be greater than 0. A negative number divided by a negative gives you a positive answer. So either both of these, top and bottom, numerator and denominator, could both be negative, or numerator and denominator could both be positive. Well, let's set it up. Let's first make both of them positive. So I take the x plus 3 to make it positive means bigger than 0. And at the same time, x minus 2 positive means greater than 0. Or they could both be negative. So I take the numerator. To make it negative means I make it less than 0. And the denominator has to be negative. So I take the x minus 2 and make it less than 0. Here x becomes greater than a -3 and x becomes greater than 2. Which one represents the points in both? It's the x greater than 2. If that doesn't make sense to you, go ahead and graph them both on a separate graph and then see the ones that are graphed in both. Here x is less than -3, x is less than 2. You want the parts that are in both. These numbers are shaded over here as well as there. These numbers are the ones in both. So I have x less than -3. So I graph those. -3, +2 is over here. Less than -3 is this. Greater than 2 is this. If this had been an equal sign, I would have the dots filled in. Pretty easy, straightforward so far. Okay. I'm going to make life a little bit more challenging here now. So far, this is what we've done. We've taken two numbers, times themselves to be greater than 0. We said they had to both be positive or they had to both be negative. We're going to switch that now. What we're going to do is switch this sign. We're going to make it the other way, less than. So here we go. This is the one we had, but now we're going to change it to a less than. This is the one we just got done with. But what's different if it's less than 0? That would mean it's negative. Well, one way to get a negative product would be like a +7 times a -8. Would you agree positive times a negative is a -56, which would be less than 0, like it is right here. So one way is to make the first one positive and the second one negative. Or I could also do it the other way. Rather than a positive 7, make the first one negative. And rather than a negative 8, make the second one positive. Because that also would give me a negative 56, which would be less than 0. Basically, we're saying they got to be opposite signs to get a negative. A and C have to have opposite sides for their product to be less than 0, or their product to be negative. So I take them, I either make the first one negative, second one positive, or I do it the other way around. Make the first one positive, second one negative. Remember what we did up here is we made them the same. Both positive or both negative. Now we're saying make one of each. Because I know if I have a negative times a positive, I'll get an answer less than 0. So to make the first one negative, I make A less than 0. That means it's negative. And at the same time, I need the second one, so I have an and. C has to be greater than 0 or positive. Or take the first one, A, to make it positive, greater than 0. At the same time, make the other one negative. Again, that's hard to understand, but go through that logic here, because that's going to be crucial for us. Okay, let's take an example. Took one that we had before. The only thing I did is this, I made that into a less than sign. So make sure that you catch that. The theory we're going to use is right here. Two things are multiplied and their product is less than 0. Means you got to either have a negative times a positive, or you got to have a positive times a negative. They got to be opposite signs. One's got to be less than, one's got to be greater than. Well, let's apply that principle. These are the two factors for that one. So let's make the first one negative. That would mean x minus 4. First one is negative, less than 0. At the same time, the second one is positive. Or I can go the other route, make the first one positive, greater than 0, make the second one less than 0. Again, make certain that you can go from here down to here, that you understand why. Now I just solve for each x. Bring the 4 across, bring the 3 across, bring the 4 across, bring the 3. Here again is that word and. I want the points that are in both. Okay? Again, if you don't see it, because it is kind of tough, but watch what I'm going to do. I'm going to graph it up here once. I have a negative 3, positive 4. Less than 4 would be all of these numbers. Greater than negative 3 would be all of those numbers, correct? I want the ones in this one and that one. That means I want them in both. Well, these numbers over here are not in both. They're only in one. These numbers right through here are shaded in both graphs. These numbers over here are not. Well, what are these numbers? Watch how I'm going to write this. These numbers are the ones between negative 3 and 4. They're greater than the negative 3, but they're less than the 4. So when I combine these two, I get that inequality from a negative 3 to x to 4. Look at this side once. I want the points in here, and at the same time, they got to be in there. Well, let's graph those separately once. Again, I know some of you don't need to do this graphing like I am up here. Greater than 4 would be all of these. Less than a negative 3 would be all of those. Notice here they're only graphed in one spot. Here they're not graphed at all. And here they're only graphed in one. There are no numbers that are in this one and in that one. There are not any numbers graphed twice. So this one we say is the empty set. Doesn't have any numbers that are graphed in both. This one is my answer, and we graph it. So I locate the negative 3, and I go between those two numbers. If there had been an equal sign here with it, less than or equal to, then I would have the equal sign coming along. Okay? Again, because this one was less than, I needed opposite signs. These had to be opposite, one less than, one greater than. Opposite here, greater than and less than. Crucial. Let's take this one once again. Notice less than. That fits this principle in red. If I have two numbers that are being multiplied, it means either the first is negative and the second is positive to have a negative answer, or the first one's positive and the second one is negative to get a negative product. To make it the first one negative, I make it less than 0. That means it's negative. Second one positive makes it greater than 0, or I can go the other way around. Remember the factors here? I can take out an x. I'll be left with 3x minus 4. Sometimes those factorings are so easy that they're actually hard. If there's no number, look to just take out an x or maybe an x along with a number. Well, let's finish this one up. Because it's less than 0, you got to have opposite signs. So let's make x negative. Means it's less than 0, and at the same time, 3x minus 4 has to be greater than 0. One had to be less than 0, one had to be greater. Or take the first one, make it positive, which makes it greater than 0. And at the same time, take the second one, 3x minus 4, and make it negative or less than 0. This one's already solved for 0, or for x, excuse me. This one, I bring the 4 across, divide by 3, and I would end up with 4/3. Here, x is greater than 0, already solved for x. Here, x would be less than 4/3. Okay? I want the points that are in both. Well, you could do the graph here, but this one's not going to have any points in both. Here, there are points that are greater than 0, and at the same time, they're less than 4/3. Those are all the points in between the 0 and the 4/3. That becomes my final answer. So I locate the 0, locate the 4/3, all the points in between look like that. Double check these red to make sure you understand how you apply it, whether it's greater than or less than. You'll get some of each in your assignment. Remember, your assignment 9-6 is assigned today, due on Friday. And we're going to have one review here on Wednesday, and we're going to take this coming Friday off. So one more class or one more lecture on a review, and then we'll be ready to go. Have a good rest of your day.